On July 18, 2001, a freight train carrying hazardous chemicals derailed inside a tunnel beneath downtown Baltimore. What started as a routine transit became a 5-day inferno that burned at 1,800 degrees, ruptured a century-old water main, and brought the busiest rail corridor in America to a complete standstill. A single tunnel nearly broke the entire East Coast transportation network. The Howard Street Tunnel runs for 1.7 miles directly beneath downtown Baltimore, Maryland, connecting the city's Camden Station area to Mount Royal Station on the other side. The Baltimore and Ohio Railroad built it between 1890 and 1895 as part of the Baltimore Beltline, creating a vital freight connection that avoided the congestion and disruption of street-level rail traffic through a growing urban center. For over a century, this single-track passage served as the only direct freight rail link between Philadelphia and Washington, D.C., making it one of the most important tunnels in the entire American rail network. Construction crews used cut-and-cover methods in the urban sections and deep rock excavation where the tunnel passed through harder ground. They lined the walls with brick averaging 3 feet thick, creating a structure designed to last generations. The tunnel follows Howard Street for much of its length, descending from the west portal at a gentle grade before climbing more steeply toward the east portal. Workers built it in an era before modern ventilation systems, fire suppression technology, or emergency access points became standard features of underground rail infrastructure. By 2001, CSX Transportation owned and operated the tunnel as part of their Baltimore Terminal subdivision. The passage handled between 28 and 32 freight trains every day, carrying everything from consumer goods to industrial chemicals to agricultural products. The tunnel had become essential to East Coast commerce, but it retained the basic design limitations of its 19th century origins. There was no dedicated ventilation system to clear smoke in an emergency. There were no fire suppression systems to contain a blaze. The only access points were manholes spaced along the route and the 2 portal entrances at either end. The tunnel also suffered from chronic water intrusion. Built below the water table, groundwater constantly seeped through the aging brick liner, causing corrosion and structural issues over decades of service. CSX conducted annual visual inspections, but these lacked detailed documentation. No comprehensive structural assessments addressed the known problems. The 1999 renewal project replaced rails and ties but didn't fix other geometry issues in the track. This aging infrastructure carried hazardous materials through a major American city every single day. On the morning of July 18, 2001, CSX freight train L41216 departed Florence, South Carolina, bound for Philadelphia. The consist included 60 cars pulled by 2 locomotives, stretching about 4,500 feet long and weighing 3,730 tons. Of the 60 cars, 31 were loaded and 29 were empty. The cargo included paper products, pulpwood, plywood, soy oils, and other standard freight materials that move through the tunnel regularly. But 8 of the cars carried something more dangerous. Tank cars loaded with hazardous materials traveled as part of the consist, including tripropylene, hydrochloric acid, and di-2-ethylhexylphthalate. Tripropylene is a highly flammable liquid similar to petroleum products. Hydrochloric acid releases toxic fumes when exposed to heat. These chemicals move through urban tunnels across America as part of normal railroad operations, with safety protocols designed to minimize risk during routine transport. The crew consisted of an engineer and a conductor who performed routine inspections before departure and found no issues with their train. The weather that day was hot and dry, with Baltimore experiencing drought conditions that had actually reduced the usual groundwater seepage inside the tunnel. The crew departed West Baltimore Yard at 2:37 in the afternoon and headed toward the Howard Street Tunnel at normal operating speed. At approximately 3:04 p.m., the train entered the west portal of the tunnel, traveling eastbound at 23 miles per hour, just below the posted 25 mile per hour speed limit. The tunnel stretched dark and confined ahead of them, the brick walls close on either side of the passing freight cars. Everything appeared normal as the train moved deeper into the passage beneath downtown Baltimore. 4 minutes later, everything changed. At 3:08 p.m., roughly 1,343 feet into the tunnel, something went wrong. The train experienced an uncommanded emergency brake application when the air brake lines severed between the 45th and 46th cars. The separation caused the emergency brakes to engage automatically, bringing the lead locomotives to a stop about 1,850 feet from the east portal. Behind the locomotives, 11 cars had left the rails. Cars 46 through 56 derailed in the confined space of the tunnel, piling against each other in the tunnel walls in the darkness. The crew felt the train stop but couldn't see what had happened behind them. The radio relay system that normally allowed communication inside the tunnel had failed because the derailed equipment damaged the infrastructure. The 47th car, a hopper loaded with calcium carbide residue, appears to have been the first to leave the tracks. Later investigations suggested the south side wheels climbed over the north rail, possibly due to an obstruction on the track combined with minor geometry issues at a point where the tunnel grade changed. Computer simulations would later confirm that a small obstruction of just 6 to 12 inches under these conditions could cause wheel climb and derailment. The 52nd car carried 28,600 gallons of tripropylene in a DOT 111A tank car. During the derailment, something punctured the tank near the bottom, creating a hole about 2 inches in diameter. Investigators later found that a disconnected braking system linkage bar aligned precisely with the puncture, suggesting it had been driven through the tank wall during the violent derailment sequence. Tripropylene is a flammable liquid that can auto-ignite when exposed to air under certain conditions. The escaping chemical found an ignition source, whether from sparks generated by the derailment or from exposure to the hot summer air inside the tunnel. Flames erupted in the confined space, spreading immediately to adjacent derailed cars loaded with combustible materials like paper, pulpwood, and plywood. The tunnel had become a furnace. The crew in the locomotives knew something had gone wrong, but they couldn't communicate with dispatchers through the damaged radio system. At 3:13 p.m., they used a personal cell phone to contact a Baltimore trainmaster who relayed the information to the dispatcher. The crew reported that the train had stopped and they suspected a problem, but they couldn't see the fire burning in the darkness behind them. By 3:26 p.m., the crew detached the locomotives from the rest of the train and drove them out the east portal, stopping about 450 feet beyond the tunnel exit. They'd escaped, but they still didn't fully understand what was happening inside the tunnel they had just left. A hotel security director near the derailment site reported a strong rumbling to 911 and CSX around the same time, suspecting something had happened in the tunnel beneath the streets. The information moved through various channels until the CSX chief dispatcher confirmed that hazardous materials were involved and requested emergency assistance at 3:51 p.m. Smoke began appearing around 4 p.m., rising from a nearby sewer grate as the fire inside the tunnel found paths to the surface through underground connections. The sight of smoke emerging from the street in downtown Baltimore immediately escalated the crisis. The Baltimore City Fire Department received notification at 4:04 p.m. and arrived at the Mount Royal portal by 4:10 p.m., but thick smoke and intense heat prevented any attempt to enter the tunnel. Inside, the fire was growing rapidly. Temperatures on the tunnel walls reached 1,500 degrees Fahrenheit in some areas and climbed as high as 1,800 degrees in others. The derailed tank car containing hydrochloric acid ruptured through a fitting, releasing approximately 2,554 gallons of the corrosive chemical. The combination of burning tripropylene, combustible cargo, and toxic fumes created conditions that no firefighter could safely enter. The tunnel had become inaccessible, and the fire was just getting started. The incident commander arrived on scene and consulted with hazardous materials experts about the risk posed by the burning chemicals. By 5:07 p.m., they determined that no immediate explosion or vapor release risk warranted mass evacuation of downtown Baltimore. Instead, authorities issued shelter-in-place orders for residents in blocks along the tunnel path and evacuated areas immediately around Camden Yards Stadium. At 5:45 p.m., civil defense sirens that had not been used since 1952 activated across the city to alert the public. Media outlets broadcast emergency notifications warning people to stay indoors and avoid the downtown area. The fire department escalated their response to 5 alarms, bringing 150 firefighters to the scene. But the intense heat and toxic fumes meant they could only watch and wait. Direct firefighting inside the tunnel remained impossible. Instead, crews positioned themselves in manholes along the tunnel route, monitoring conditions and preparing to apply water and foam when temperatures allowed. The plan was to fight the fire from access points rather than entering the burning passage directly. Then, at approximately 6:15 p.m., something unexpected happened that would change the entire situation. Water pressure dropped suddenly at the Montebello treatment plants, indicating a major break somewhere in the system. Security cameras captured water erupting from the street at 6:19 p.m., and officials quickly realized what had occurred. A 40-inch cast-iron water main installed in 1894 ran directly above the tunnel. The intense heat from the fire below had caused thermal expansion in the old pipe, stressing the brittle iron until it ruptured. Water began flooding into the tunnel and onto Howard Street simultaneously, creating chaos on the surface while inadvertently fighting the fire below. 14 million gallons would pour into the tunnel before crews could close the valves. The water main rupture created new problems, even as it helped suppress the flames. Howard Street flooded as water poured from the broken main, closing major intersections and creating gridlock across downtown Baltimore. The flooding damaged underground infrastructure, including power cables that caused outages in 1,200 buildings and fiber optic lines that slowed internet traffic across the region for 36 hours. Firefighters finally began active suppression efforts on July 19th, working through a manhole at Howard and Lombard Streets to apply foam and water directly into the tunnel. They worked in protective gear, battling residual heat and toxic fumes while trying to extinguish the remaining flames. The confined space and damaged infrastructure made every aspect of the operation difficult and dangerous. The fire continued burning through July 20th, July 21st, and into July 22nd as crews worked to remove derailed cars and access the remaining hotspots. Equipment had to be brought in through the tunnel portals, a slow process given the damage and debris blocking the passage. Each car removed revealed more destruction and allowed firefighters to reach areas that had been inaccessible. The water main was finally repaired on July 22nd, stopping the flow that had flooded both the tunnel and the streets above. Workers began assessing structural damage to the tunnel itself, checking whether the intense heat and flooding had compromised the century-old brick liner. The fire was declared fully extinguished at 7:42 a.m. on July 23rd, 5 days after the derailment occurred. The tunnel reopened at 7:45 a.m., allowing freight traffic to resume through the critical passage. 5 emergency responders suffered minor injuries during the response, but remarkably, no one died in an incident that could easily have been far more deadly. The fire was out, but the damage extended far beyond the tunnel itself. The 5-day closure of the Howard Street Tunnel sent shockwaves to the American rail network. The tunnel normally handled 28 to 32 freight trains every day, and every one of those trains now had to find another route. CSX rerouted traffic through Cleveland, Albany, Harrisburg, and Cumberland, detours that added 3 to 4 days of travel time and created massive backups in rail yards across the eastern United States. The supply chain disruption affected businesses that depended on timely freight delivery. The tunnel served as a vital artery for cargo moving to and from the Port of Baltimore, and the closure created bottlenecks that rippled through the entire East Coast logistics network. Rail yards filled with trains waiting for capacity on alternate routes, and shippers faced delays that cost money with every passing hour. Passenger services suffered equally. The Northeast Corridor, the busiest passenger rail route in America connecting Boston, New York, Philadelphia, Washington, and intermediate cities, experienced partial shutdowns and significant delays. While the Howard Street Tunnel itself carried freight rather than Amtrak trains, the disruption affected shared infrastructure and created cascading problems across the regional rail network. Marked commuter trains on the Camden Line were suspended entirely, forcing thousands of daily commuters to find alternative transportation. The Maryland Transit Administration implemented bus shuttles between key stations, but the replacement service couldn't match the capacity or convenience of rail. The Central Light Rail line shut down for over 7 weeks as crews dealt with damage from the flooding and fire. Norfolk Southern, which had trackage rights through the tunnel, also rerouted their operations. The single-track passage that had seemed adequate for daily operations proved to be a critical vulnerability when it suddenly became unavailable. The entire East Coast rail network had been designed around the assumption that this tunnel would always be open. One tunnel closure proved that the system had no backup plan. The effects of the derailment extended far beyond the railroad into every aspect of Baltimore city life. The flooding from the ruptured water main closed major intersections for 5 days, creating traffic gridlock that stranded commuters and disrupted business operations across downtown. Howard and Lombard streets became impassable as water damage and emergency operations blocked normal traffic patterns. Power outages affected 1,200 buildings when the flooding damaged underground electrical cables. Businesses lost revenue, offices closed, and residents dealt with the inconvenience of unreliable electricity while crews worked to restore service. The Inner Harbor, Baltimore's premier tourist destination, closed to boat traffic as authorities assessed environmental conditions in the waterway. 3 Baltimore Orioles baseball games were canceled due to smoke and safety concerns around Camden Yards, costing an estimated $5 million in lost revenue. The team and stadium operators would later pursue legal claims against CSX for the financial losses. Underground explosions from residual chemicals occurred weeks after the main fire was extinguished, reminding residents that the incident's effects continued even after the flames were out. The severed fiber optic cables carried WorldCom's internet traffic, and the damage slowed connections across the region and affected transatlantic communications during a period when the internet was becoming increasingly essential to daily life. The 2001 incident demonstrated how vulnerable critical communications infrastructure was to physical disruption. Environmental response teams from the Maryland Department of the Environment and the United States Coast Guard arrived within 3 hours of the initial notification. They conducted air quality monitoring throughout the event and found no long-term threats from the chemical release. Cleanup operations eventually removed 1,400 tons of contaminated soil and 3,000 gallons of material from drainage systems. The total cost of cleanup and repairs reached approximately $12 million. A railroad accident that had become a citywide emergency affecting hundreds of thousands of people. The National Transportation Safety Board launched a comprehensive investigation into the derailment, spending 3 years examining every aspect of the incident. Investigators analyzed track conditions, equipment maintenance records, train handling procedures, and computer simulations of the derailment sequence. They interviewed crew members, examined surviving equipment, and consulted with engineers and safety experts across the railroad industry. The investigation faced a fundamental problem. The fire, flooding, and cleanup operations had disturbed the accident site so thoroughly that physical evidence was limited or destroyed. The intense heat had damaged equipment and track components. The 14 million gallons of water had washed away materials in altered conditions. Emergency response and recovery operations had necessarily moved debris and equipment before investigators could examine everything in place. Despite exhaustive analysis, the NTSB couldn't determine a probable cause for the derailment. No pre-derailment defects were found in the rails, which had been inspected on July 9th and met Federal Railroad Administration standards. No broken rails or wide-gauge issues existed at the derailment site. Equipment inspections, including brake systems, showed compliance with regulations. A missing center pin in one car was examined but determined to be non-casual. The most likely scenario, supported by computer simulations, involved an obstruction on the track combined with minor geometry deviations at a point where the tunnel grade changed. Wheel marks on the north rail supported this theory. However, no obstruction was found during the investigation, possibly because it was consumed by fire or washed away by flooding. Sand discovered at the site was attributed to erosion from the water main rupture rather than pre-existing track conditions. The investigation did criticize CSX's inadequate maintenance documentation and recommended improved communication between the railroad and Baltimore City officials regarding emergency preparedness for tunnel incidents. 3 years of investigation ended without answers about why the derailment occurred. The 2001 Howard Street Tunnel fire became a turning point for railroad safety and infrastructure planning. Federal agencies launched studies examining alternatives to routing hazardous materials through urban tunnels, including new alignments that would bypass Baltimore entirely. The estimated cost ran into billions of dollars, but the incident had demonstrated the real risks of the existing infrastructure. Tank car safety standards evolved directly because of the incident. The DOT 111A tank car that ruptured and released tripropylene was identified as vulnerable to puncture during derailments. New regulations phased out these older designs, replacing them with cars featuring thicker shells, head shields, and enhanced thermal protection. The phase-out deadline extends to 2029, ensuring that the type of car involved in the Baltimore fire will eventually disappear from American railroads. Communication protocols between CSX and Baltimore City officials improved significantly. Emergency preparedness plans were updated to specifically address tunnel fire scenarios involving hazardous materials. The failure of the radio relay system during the derailment led to requirements for better communication infrastructure in critical tunnel locations. The incident accelerated planning for the Howard Street Tunnel expansion project. The century-old tunnel's limitations had been known for years, but the fire provided urgent evidence that modernization could not wait indefinitely. The project aims to accommodate double-stacked freight containers, increasing capacity for the Port of Baltimore and reducing bottlenecks on the East Coast rail network. Environmental clearance came in 2021. Federal funding of $125 million was secured in 2019, and the total project cost reached $566 million by 2024 estimates. Construction began in 2022 with a target completion date of 2027. A disaster that exposed critical vulnerabilities finally forced action to address them. The Howard Street Tunnel fire burned for 5 days beneath downtown Baltimore, disrupting freight traffic across the East Coast, shutting down passenger rail service, flooding city streets, and demonstrating exactly how vulnerable America's rail network was to a single point of failure. The tunnel that almost collapsed the nation's rail network became a lesson in infrastructure resilience that continues shaping policy today. Hit that like button and subscribe for more stories of the disasters that changed transportation forever.